Welcome to Mastering Machines, where we discover tomorrow's reality.
Hello everyone, welcome to Mastering Machines, where we discover tomorrow's reality. When I'm talking about Groq, I'm not talking about Elon's AI baby, I'm talking about Groq with a Q. Groq captivated the AI community from its flash-like speed. It worked on my phone, and it even created a novel for someone in about 3 seconds. That's what kind of speed we're talking about. It's performing better than Travis Kelce at a Super Bowl after party. Hi-oh! Groq CEO Jonathan Ross previously worked at Google. Ross previously invented the Tensor Processing Unit. That's the chip that drives Google's machine learning software. So obviously he was huge and instrumental in the machine learning efforts of Google. Jonathan has been making his rounds on a number of news outlets, most notably his interview with CNN that included a pretty drunk reporter asking him questions in the middle of Cairo. Also, he had this pretty sweet kind of zinger on Hacker News when one of his previous employees started a competing business, and he basically told the grift that he was doing in the comments. Touche. But the really interesting thing about Groq, outside of its blazing speed, is the architecture of the chips and what is really under the hood of the program and how it works. Groq is a radically different kind of AI architecture. Among the new generation of AI chip startups, Groq distinguishes itself with a unique approach centered around its compiler technology for optimizing a minimalist yet high-performance architecture. The cornerstone of Groq's innovation is this compiler-first method that kind of eschews the complexity for tailored efficiency. At the core of Groq's design is an almost surprisingly minimalist structure that eliminates unnecessary logic in favor of raw parallel throughput. The hardware is comparable to an ASIC, an application-specific integrated circuit, finely tuned for machine learning tasks. However, unlike a fixed function ASIC, Groq uses a custom compiler that can adopt and optimize across various models. This blend of streamlined architecture and intelligent compiler differentiates Groq. The key observation is that many AI chips accumulate components like GPUs, adding unnecessary hardware in bulk. Groq returns to what a lot of the technology world calls first principles, acknowledging that machine learning tasks primarily require massive parallelism over simple data types and operations. By dispensing with generic hardware and concepts such as locality, the design maximizes throughput and efficiency. Enabled by Groq's compiler, which acts as an intermediary between software frameworks like TensorFlow and the hardware, it analyzes and optimizes neural network graphs, tailoring and mapping them onto the underlying architecture for accelerated execution. The compiler decomposes computations into the smallest possible operations to enhance that parallelism, so it's basically running faster. And it also facilitates capabilities such as a batch size one inference, ensuring all hardware is efficiently utilized. Importantly, Groq developed its compiler before finalizing the actual hardware design. Insights from the software actually influence the architecture. Usually it's the other way around in most cases with technology companies or firms. This co-design process enabled optimization specific to inference tasks without the constraints of legacy designs. The compiler also offers deterministic runtime guarantees, facilitating reliable scaling. Together, Groq's compiler and architecture create a streamlined, powerful engine that powers machine learning inference. The innovative compiler first methodology allows for custom optimizations that balance flexibility with performance, rather than adding all of this complexity that's seen in other kind of like architectures such as GPUs. Groq demonstrates that less can be actually more when software and hardware are harmoniously aligned. A pretty persuasive argument is we see AI workloads from, AI graphic software to just the large language models continue to evolve. Also, a kind of a footnote of what Groq is doing is that it came in at a very specific time where OpenAI is kind of getting worse, and a lot of people are agreeing that a lot of the performance of it is getting worse. And OpenAI just had a nasty outage that lasted for like 2 days, where basically it was for a lot of people, it's hallucinating, speaking Spanish, saying all these different things that really made people wary of using OpenAI and possible products or just their regular tools. But that's it for today. Like, subscribe. Remember, discover tomorrow's reality.